Welcome to the two-plane balancing tutorial for turbofans. The first step is to identify the electronic components in the soft case and position the sensors. We assemble the holder to the optical sensor to place it on the balancing machine's frame. We plug the cable and screw it to avoid signal problems. We plug the other end to the interface. Now we screw the vibration sensors on the soft bearing suspensions without twisting the cable to avoid damages. It's very important to turn the entire cable when you screw the sensors. Sensor for plane 1 is connected on port 1A and sensor for plane 2 goes on port 1B. On the next step, we adjust the distance between pedestals according to the length of the turbofan. It's very important to leave enough distance between the pedestals for the belt so it doesn't touch the supports. We put the belt around the shaft. We place the tensor guide of the transmission. We place the axial holders to prevent the turbofan to move horizontally while it's spinning. For example, if the shaft of the rotor has a step that avoids the rotor to move to the left, you won't need to use the left axial holders. We cut a small piece of the reflecting tape included in the optical sensor's plastic bag. We stick it in the internal face of one of the turbofans, where the laser beam can see it. We connect the interface to the USB port of the computer, the two LEDs will blink twice, and finally the port 1A will stay on. Press the combination Shift-Alt-D and select line USB. We plug the machine to the wall socket. Now we test the optical sensor using a piece of reflecting tape. Pass it in front of the tape and the blue light behind should blink. Remember, the laser dot must be pointed horizontally on the same side of the accelerometers. Select New Balance. We select the parameters for the type of rotor we want to balance. No filter if we don't know the rotation speed. Record time between 3 and 6 seconds are convenient for rotors turning above 700 RPM. Finally, we select soft bearing suspensions mode. On the Balancing Wizard tab, we choose the diagram looking the most to our rotor and we input the dimensions requested on it. We input the rotor's mass, we select two planes, and we choose left rotation CCW or right rotation CW clockwise, seen from plane 1. We set the desired quality grade for this balancing and the nominal working speed of this rotor. We choose if we are going to add or remove mass. The mass of these suspensions is 150 grams. In case you need to recover this configuration later, choose a name and save it. Start up the balancing machine and increase the speed until you reach the desired balancing speed. We can use the tachometer to check it. We record the signal from plane 1 and once the recording is finished, the signal will appear on the central window. We press the switch button on the interface to select plane 2 and we also select plane 2 on the Digivibe by clicking on the right polar graph or plane 2 on the left column and we start the recording. Immediately after the two signals are recorded, we will see the correction masses and angles for both planes on the left column. We weight the correction masses using a precision scale and we place them at the angle indicated by the Digivibe. Seeing the rotor from plane 1, the 0 points always horizontally to the right. From this mark, we measure the angles counterclockwise. If you look from plane 2, the mark is on the left and you measure the angles clockwise. We start up the machine again and we measure vibration from both planes. Repeat this process until you get the desired quality grade. The yellow dot on plane 1 indicates that the vibration is close to the desired quality grade, but it's not good yet. On plane 2, the green dot indicates that the quality grade has been achieved and it's better than the one we specified. Let's place the new counterweights to improve the balancing. These weights are smaller because they are for fine-tuning. In this example, we put plasticity. We start up the machine again and measure vibration on both planes. Now both indicators are green, which means that we have reached the required quality grade. Now you can generate your balancing report going to Tools. Normally on this kind of rotors we need to grind on the opposite side to remove mass. This is the end of this balancing tutorial. We hope it has been very useful to you. For further information or assistance, please visit us at www.ERBESSD-instruments.com. Thank you.